Okay, fun little project. We've got to take this bronze tube, which is rubber lined, and reduce the diameter. Half of it is going to get turned to that, and the other half is going to get turned to that. And we'll turn the larger end first, swap it around end for end in the setup, and then turn the other diameter. And this is the simplest way to go about it, with the steady rest between the chuck and the carriage. There's no great way of setting up a center on this end and still being able to turn it. Eventually you got to get at that end to turn it. So this is the simplest way. And we've set up the steady rest, roughed it in with the dial indicators set on a sled running up and down the bedway, and then we've got the dial indicators set on the carriage, and we've put our two marks at 90 degrees to each other at the center line height. So there's one mark there and there's one mark there. Gets our indicators running where they ought to be. And now the moment of truth, after we've got everything set up. We'll look at one indicator here first. It moves around a bit, but that's okay. The being a hollow tube, it actually crushes ever so slightly where your chuck jaws are bearing against it. Causes it to deflect. So you can only chase it down to the last thousandths or so, and that's about as good as it gets. So that's pretty good. And with the dial indicator set on the carriage, like we just traversed, when we get our tool post swung into position and take our cut, that tool will be traveling exactly the same path as that dial indicator. And because the component is level or parallel to the bedways on this axis, there won't be any tilt to it, so it shouldn't end up with any appreciable taper in it. It's very much similar to how we did the dialing a steady rest with a sled sort of routine. It's just that we've got the steady rest on the between the chuck and the carriage instead of the other way around.